Okay, have you ever really thought about a technical drawing as a language? I mean, not just a bunch of lines on a page, but a really precise universal language, one that lets a single idea be understood perfectly by anyone, anywhere in the world. It's a pretty wild idea, right? So let's break down how this language actually works.
Just think about that for a second. How on earth do you communicate the exact size, the shape, the function of a really complex object across entire continents and massive language barriers? Well, the answer is a shared set of rules. It's a common grammar for design.
So here's what we're going to cover. We'll start with what British standards actually are. Then we'll learn the basic grammar of lines and symbols. After that, we'll see how dimensions add that super precise meaning. And this is the important part. We'll show you why mastering all of this is your absolute blueprint for success in higher graphic communication.
Right. So what exactly is this rule book that basically everyone in the industry uses?
British standards, or just BS for short, are the agreed-upon rules that turn a simple drawing into a completely unambiguous instruction manual. They get rid of all the guesswork and make sure that a line drawn in one place means the exact same thing to someone reading it thousands of miles away.
And when I say they cover everything, I mean everything. From the type of line you have to use for a hidden edge right down to the way you lay out your title block, yeah, there's a standard for it. It's this consistency that makes the whole language work.
The big one you need to know is BS 8888. But here's the really crucial part. It lines up with international standards, ISO standards. So when you learn this, you're not just learning some local dialect, you're becoming fluent in the global language of technical design.
Okay, so if this is a language, what does its grammar even look like? Well, every language has an alphabet and vocabulary, right? For technical drawing, it's really no different. The absolute foundation, we're talking the alphabet of this language, is line types. You can't just draw any old line you feel like because every single style has a very specific job to do. It's a visual code.
Let's take this one for example, a hidden detail line. This isn't just some dashed line to look cool. It's communicating something vital. It's basically shouting, hey, there's an important edge or feature right here, but just so you know, it's on the other side of the object, you can't see it from this angle. Another super crucial one is the center line. You see this long dash dot pattern, and it instantly tells you where the axis of a circle is, or the midpoint of a symmetrical part. It's an instant signpost for all the key geometric features.
And hey, if lines are the alphabet, then you can think of symbols as the words. Instead of having to write out this part has an external screw thread or this wall here is made of brick, we just use a standardized symbol. It's way more efficient and, you guessed it, totally universal. All right, so we've got our letters and we've got our words. Now it's time to build some sentences. And in the world of technical drawing, that means adding dimensions.
This is where things get really serious. An idea is great, sure, but a product can only be made if its exact size is communicated perfectly. A mistake of just a single millimeter here could be an absolute disaster, so the rules for dimensioning are incredibly strict and crystal clear.
So, one key technique is using running dimensions. See how every single measurement starts from that one line on the left? That's called a datum. You can think of it like a home base for all your measurements. By always going back to that same point, you stop tiny errors from adding up, which makes it a super accurate method.
Now, the other main method is chain dimensioning. Here, instead of going back to a home base, you're measuring each feature one after the other, kind of like links in a chain. This is perfect for when the distance between two features is more important than where they are on the whole object. Knowing which one to use is a really key skill.
This just goes to show you how detailed the standards really are. I mean, even for a less common shape like an ellipse, there is a specific rule. You have to dimension the longest and the shortest diameters, the major and the minor axis. No guesswork allowed. Okay, now for a really crucial real-world concept, tolerancing. The thing is, in reality, no machine can make something exactly 50.0000 millimeters. It's just not possible. So tolerances tell the manufacturer what the acceptable range is. Can it be 50.1? Is 49.9 okay? This tells them the upper and lower limits for the part to still work perfectly. So, we've covered the what and the how, but now let's get to the most important question for you right now, the why. Why is all this your key to success in your course?
You know, out in the professional world, these standards are completely non-negotiable. They prevent multi-million-pound mistakes, and they make sure that a part designed in Glasgow will actually fit a machine being built in Seoul.
This stuff is the language of modern engineering.
That's all great, but let's bring it right back to you and your coursework. What is the single most important reason for you to master British standards right now?
The answer is really simple. Forget the factory floor for a minute and just think about your grade. This is a direct quote from your textbook. It says you are awarded marks just for following these standards. The correct line types, the right dimensions. These aren't just tiny details. They are, and I'm quoting here, easy marks to collect.
So let's just be blunt about it. Learning this language isn't just some abstract exercise for you. It is the most direct way to pick up marks that other people might miss. This is your blueprint for turning a good assignment into a great one. So there you have it. You have the rules, you have the grammar, and you have the vocabulary of a truly universal language. The only question left is, what amazing ideas are you going to communicate with it?